Hi everyone, so today is day 26 of September LeetCoding challenge, and on this day we'll be solving this problem, transform to chessboard. So in this problem we have been given an n cross n binary grid called board, and in each move we can swap any two rows with each other or any two columns with each other. And by doing so we have to like transform this binary grid into a chessboard. So by chessboard I mean that every cell, like we have alternating pattern all over the board. So we are like not encountering any uh, same number adjacent to any number. Like for example, if there is one here, then there shouldn't be one adjacent to it. So suppose here one here, there is one here. So like adjacent to in all adjacent in all four directions, there should be only zeros, not one. So this is what the grid chessboard pattern looks like. So by doing minimum number of swaps, so by swap I mean that we can swap any two rows with each other or any two columns with each other. So by doing the minimum numbers of swaps, we need to transform the board into a chessboard. And it may be possible that it is not possible to convert this binary grid into chessboard. So in that case we have to return -1. And we can take a look to the sub examples. So this is the example one. So in this example, like one swap is being made between this, right? We can see that one swap is made between these two columns. So what happens, this column, this is the orientation, this is the look of the board after this swap, and after that one swap is being made. So we can see that this, no, we can see that by doing this we can arrive at this. And now what we need to do, we need to have 1010. Yeah, so one swap is made here, right? Actually what is happening that here the color of the one was yellow and here the color of the one was blue, so that got me confused. So one swap is being made here. So after doing these two swaps, we can see that the final appearance of the board is a chessboard. So we can see that by doing two swaps, we have arrived to this chessboard. So the answer is 2, because it is not possible to convert this binary grid into a chessboard in just one move. So we can take a look to the another example. So in this example, we don't need any swaps because it is already in the chessboard form. So that's why the output is 0. And here, like, it is not possible to convert this binary grid into chessboard. So the reason is that if we will swap these any column, like if we will swap this, this will only change 1 or 0. And like there is alternating kind of thing here from the column side, but there is no alternating pattern in the row side. So if we will swap these two, like, it won't cause any effect. So kind of like it is evident that we cannot swap it to form a chessboard. Now we can take a look to the constraints. So we can see that the number of rows is also n and number of columns is also n. So it is a square, and yeah, this n can vary from 2 to 30, and the numbers contained inside the board are either 0 or either 1, right? So now we can discuss how to solve this problem. So there is one important thing that is necessary for this binary grid to be able, like to be convertible into the chessboard pattern. So the important thing is that every, like, if we are doing swaps between rows, this will only interchange these rows, right? So there is one row this, there is one row this, so there are 4 rows, right? So if we are making swaps with a row between rows, then that will only place this row below, or like it will just change the orders of the rows. So this bitwise pattern will remain constant if we are doing swaps with rows. So now let us try to consider these swaps with columns, right? So in order to, yeah, so in we want that after making some swaps with the columns, all these columns, like all these, this whole board should be arranged into an alternating pattern. So for that, there is one important condition, that all the rows should either be equal to each other, or they should be just opposite to each other, if we are considering the this 0 and 1 pattern. So here we can see that the first row is 0 1 1 0 0 1 1 0, and here the two rows are just opposite of the first two rows. So the reason between them is that suppose here these two are unequal between like first and second position, these two are unequal, and suppose here at this place these two are equal, right? So in that case what will happen, so to like make the alternating pattern, what we will do, we will make 0 1 here, because we want alternating pattern. And so we want make any swap, or if we will make any swap, we will make a swap with some cell which has got 1 here, right? So we know that 1 will come here, and so basically we will try to form a alternating pattern on the first row. So whenever we will like move this cell by making column swap, this cell will also move it with it, right? So we can see that here whatever will be the relation, so suppose here will be 0 and here will be 0. So right, so I mean that if we want alternating pattern, then these two rows may, these two rows may either be equal or either be unequal, depending on whether these two rows will be finally placed after doing the row swap. So if they are just next to each other, or they are at odd positions, then this will be 0 and this will be 1, right? So if these are differing with each other and these are equal, then for making the alternating pattern at the top column, we will have 0 and 1 here. So if we try to make an alternating pattern here, 0 1 or 1 0, then what will happen, we will get 0 0 here, or 1 0 1 1 here, something like this. So like it won't be possible to make alternating patterns on all the columns simultaneously if they all these bits are not equal to each other, all the rows are not equal to each other, or all the rows are not opposite to each other. That was what I was saying. So we just need to make sure that this condition is satisfied in this binary grid. So just in case this condition is not satisfied, so what will happen, the thing that will happen is that we will return -1, because it is not possible to achieve this chessboard pattern in the final by doing any number of moves. And if it is possible, we need to do what, we need to check the minimum number of swaps we need to make alternating pattern at the top row and alternating pattern on the first row, first column. And now we can sum these two swaps, and since we have checked for the condition of this bitwise similarity, so then if we will try to make alternative alternating pattern on the to the first column and first row, that will automatically make the whole chess binary grid look like a chessboard. So first we need to make sure that this binary thing, that this bitwise thing is being satisfied, and after that we can check whether the what are the minimum numbers to make 0 1 0 1 or 1 0 1 0, and similarly this thing here. So this is what we will be doing. So let us try to implement it. So first of all, we will be taking We will storing the size of the board. So after that, what we'll be doing will be checking whether the condition is being satisfied or not, that bitwise condition. So we will be checking only for the adjacent rows. So if these adjacent rows are like uh, obeying that condition, then obviously this whole rows are obeying that conditions, that they are either equal to each other or they are alternating to each other. So I'll be checking for I and I plus 1. That's why I have taken the limits of I less than minus 1, n minus 1. And I'll be having j equals to 1 and j less than n, j plus plus. So for the column part, I will be checking between j and j minus 1. So if greed I j is equal to greed I j minus 1. So if the first two cells are equal, then the bottom two cells should also be equal, right? So if the bottom two cells are unequal to each other, then we can return minus 1. And similarly, if the first two cells are unequal to each other and if the bottom two cells are equal to each other, then also we can return minus 1. So after checking this condition, we will need to check how many minimum number of swaps we need to make this column thing alternating and make this row thing alternating. So first we will be like considering how to get the minimum number of swaps to like form this first column as alternating pattern. So since we have like checked for this condition, so it is evident that all these bits, all these bitwise patterns are either equal to each other or just opposite to each other, right? So if we'll somehow form alternating pattern on the top column, then this will automatically form alternating patterns on all the columns, right? No, on the top row by sorry, in the last statement I mean that if we will be able to form alternating pattern on this first row, then it will automatically form alternating pattern on all the bottom rows, because all these like rows are either equal to each other or just opposite to each other. So those who are equal to each other, they will be exactly equal alternating pattern to the top row, and those who are like the rows which were just opposite to each other, then they will be the just opposite alternating pattern. So if the alternating pattern here is 0 1 0 1, then here it will be 1 0 1 0. And like after doing swaps between these columns, it will be like ensured that every row has got the alternating pattern. And to make sure that we are having alternating pattern between these uh, between each row, between adjacent rows also, then we will do the similar thing here. So after doing these swaps, to make this row wise thing, this first column as a into an alternating pattern, this will make all these other columns as alternating pattern also. So this is what we will be doing. So for making the for calculating the minimum number of swaps, what we'll be doing will be first checking whether the how many mismatches are there for this pattern 0 1 0 1. So we can see that these two are equal to each other, so there are no mismatch. Here we can see these two are also equal, and here we can see that there is a mismatch. So instead of 0, there is 1 here. So 1 1 1 has been wrongly placed. So we will increase this 1 plus plus, we will have a variable once and we'll increase its value. And here we can see that here it should be 1, but here it is 0. So we will increase zeros plus plus. So we can see that 1 1 and 1 0 has mismatched, right? So what we can do, we can swap these two variables, and by swapping these two, so by swapping, by taking this one to the position of 0 and 0 to the position of 1, this thing will decrease the value of this by 1, because now this 1 is no longer at wrong position, it has moved to the correct position. So this will decrease the value of both by 1. So if the number of mismatched ones are 4 and the number of mismatched ones zeros are 4, then it will take us 4 swaps to restore all these ones and all these zeros at their correct positions. And what if the number of mismatched ones and number of mismatched zeros are unequal? Suppose there are 6 ones at wrong position and there are 4 zeros at wrong position. So in that case, it is not possible to make this alternating pattern. So this is what we will be checking. So there are two kinds of alternating pattern possible. So one is 0 1 0 1 and one is 1 0 1 0. So we will, what we will do, we will calculate these ones and zeros for both of them, and we will take minimum number of swaps for both of these patterns. Similarly, we will do the same thing for the first column, and we will take minimum there also. And just in case it is not possible to make alternating pattern at any of the position, at any like considering row wise or column wise, we'll return -1. And if it is possible to make alternating pattern at both the positions, like we can do what, we can take the minimum here, and then add them and then return them. So this is what we'll be doing. So we can now implement this thing. So for implementing this, I'll be having swaps 1, column swaps. I can call it col swaps. So I will be having one variable for ones, and I will be having one variables for zeros. So this ones and zeros are symbolizing the how much ones and how much zeros are at wrong positions. So we can iterate over the first column, first row. So I am first considering the I mod 2 equals to 0. So I want this position to have 0 and the position, this position to have 1. So I want the orientation to look like 0 1 0 1, right, and so on. So here the correct bit to be present is 0. So just in case the grade 0 and 0i contains 1 here, then we can increase once, because 1 1 has been misplaced. And just in case we have 0 here, because here it should be 1, so we can increase the zeros variable. So after doing all this stuff, we also need one boolean to check whether it is possible to do swap or not. So I will be first initializing it with false. So if the ones are equal to zeros, then obviously it is possible to make a swap. So in that case, I will be setting this possible to true, and also call swap to ones or zeros, whatever, both, since both of them are equal to each other. So you can set it to ones or zeros, anything. And if it is not possible, then we will leave this possible equal to false and call swap equals to 0. And again we need to do same thing, but with the pattern 1 0 1 0. So in that case, what I will do, I will take, let us have this possible at the top. Yeah, so I will be doing what, I will be copying this stuff, and I can reset the ones to 0 and zeros to 0, and now the pattern is 1 0, something like this. So here it should be 1, right? And here it should be 0. So if it is 0, then we'll be doing zeros plus plus, and if it is 1, then we'll be doing ones plus plus. So if ones is equal to zeros, right, then if it is already possible, like if we got some, if this 0 equals to 1 was fulfilled in the previous pattern, then in that case we can do what, call swap. Let us make yeah, so this s is in capital letter, so we can set this call swap equals to min of call swap comma once. And just in case it was not possible, then we will set this possible to true, and this call swap equals to once. And if it is not possible to make the first row into alternating pattern, then we can return -1 here. Now if it was possible to do this, to make this first row into alternating pattern, then we can do the same thing to make the first column as alternating pattern. So we can copy all this stuff, and there are some things we need to change. We can change this call swap into row swap. This ones and zeros are already declared, so I will remove one int from here, and the first pattern will be looking for is 0 1 0 1, right? So everything is right, just we need to change this 0 I into I0, and again the same thing. So in that case we will set this row swap equals to once. I guess we have made mistake here also, right? So now the namings are okay. So after doing this, we will again reset this ones and zeros, and then we will try for this pattern. So again we need to change this one I0 0 I into I0, and here also change this row swap call swap into row swap. I guess it's okay. Yeah, so in the end we have got row swap and call swap, and if it is not possible, then it will -1 would have been returned. So we will only execute the lines that we are going to write if it is possible to do so. So we can return row swap and call swap, row swap and row swap plus call swap. This should be the answer. So for doing this, for checking the first condition, we iterated over the whole grid, and that's why the time complexity for the first part is n into m. So basically m is also n here, And for doing the second operations, the v2 did n iterations. So the time complexity is this, and we are not using any extra space, so the extra additional space complexity is order 1. So we can try to run it on the sample test cases. Okay, so what is happening is that the variable is board and I have used greed, so we just need to change the name. Yeah, almost done. Now we can again try to run it. Yeah, there is one more thing that we, line 7 character 20. Okay, we could have just changed this variable also if there were the mistakes throughout the program. And yeah, I think it should work now. Yeah, it is working on the sample test case. We can submit it. Okay, so we have got wrong answer here. 1010. I guess we have. Okay, there is one more thing. Before starting this operation, again we need to set this possible equal to false, right? Now we can submit it. Yeah, it got accepted. So thank you guys. See you again on day 27. Until then, keep leet coding.